Okay, so for number 20, first of all, I'm doing some of the evens, walking you through some of those, but you're going to do the odds for these problems, and this is going to be considered your study guide because next class period you're going to have your final quiz on solving exponential and logarithmic equations. You're still going to learn a little bit after that, stuff you'll need to know for calculus, but that will be the final pre-calc quiz. So let's look at number 20. Thought that one looked similar to some of them and was a little bit harder. So first thing you want to do is, if you look at your base, right, and you want to create same base, I always look at the smaller one first. So I see that's base 5, doesn't get smaller. I ask myself, can I replace 25 with something base 5? And yes, I can. I can replace this with 5 squared. And so then it's 5 squared raised to the x minus 4 is equal to 5 raised to the 3x plus 1. Now the bases are the same. We distribute that 2 to the x and the negative 4, so we have 2x minus 8 is equal to 3x plus 1. We then solve for x, so we subtract 2x from both sides. Excuse my dog. So we have negative 8 is equal to x plus 1. We subtract 1, so we get x is equal to negative 9. Now we should always plug in to make sure it's not extraneous. And how we do that is if we go back to the problem, so if we go back to number 20 and we plug in negative 9, we would have up here 25 raised to the negative 9 minus 4. And we'd ask ourselves, is that equal to 5 raised to the 3 times negative 9 plus 1? And so over here on the left, we would get 25 raised to the negative 13 is equal to, on the right side, we would have 5 raised to the negative 27 plus 1, so that's negative 26. And if we put that in our calculator, 25 raised to the negative 13 is 6.7 times 10, it says e, so times 10 to the negative 19th. And 5 raised to the negative 26 power is also 6.7 times 10 to the negative 19, scientific notation or calculator. So yes, since it's a true statement, we can go back and we can say, yes, negative 9 is indeed a solution. Now let's look at the next problem. So the next one, we're going to look at 24. That one's also a little different. So notice, when it's an exponential form, we first want to isolate the term with the exponent that's variable, right? So pretend that this problem said negative 5x minus 3 equals 24. You would add 3, right? Negative 5x is equal to 27, and you would divide by negative 5, and you would be done, right? So remember that. Now it's the same process, okay? We just have to use logs and natural logs. So first thing we're going to do, we're going to add 3 to both sides first. So we'd have negative 5 times e to the x is equal to 27. Now we're trying to isolate e to the x, right? Pretend e to the x is that x, so to speak, like I showed you over here. We're isolating the red bubble. So we divide by negative 5. So we have e raised to the x is equal to 27 over negative 5. Now, once you've isolated that base, I like to use logs. So what I do, I'll show you 2 different ways. I like to use logs. So I look at the side the variable is on, which is the left. I look at that base, and I apply that log base to both sides. So log base e, log base e. So log base e of e cancels, so we have x is equal to log base e of negative 27 over 5. And yes, Maddie. And you know that log base e is natural log. So in your calculator, there's the natural log button. So you hit natural log, and you negative 27/5, and we get error. There's no value. So that's why we say no solution. Just as a side note, when I like to work with logs to see actually the LOG in a base versus natural log. So whenever I see natural log, I always rewrite it as log base E, right? There's that E button on your calculator. It's about 2.714. If I see, so when I see natural log, I write log base E. But you can go back and forth, they're the same thing. Also, when you only see log and some value, right, something right there, and you don't see anything written in the base slot right here, you know it's base 10, because that's a common log. Okay, so for this section, you're going to continue to solve the rest of these exponential problems. Remember to test your values, plug them back into the original, make sure they make true statements, that when you plug in, the left side is equal to the right side when you simplify. If you plug in a value and it doesn't work, then you'd say it's extraneous, it's an error. Or when you plug in your calculator, if you get error, invalid, no solution. So sorry, I forget what I just said. My daughter keeps running around and eating things. But anyway, so you are going to do the odd problems for this section, and then for the next section, all of the answers are at the very bottom of your sheet as well. And this again is review for the next class period, where we're going to have a quiz on all of this, solving exponential and logarithmic equations. Remember to come on Zoom if you need help. Okay, so for this next page, when you look at it, you'll see that at the top, 28 to 45 are all solving logarithmic equations. We also need to check for extraneous solutions. And down here at the bottom, that's the answer key. So when you're doing all of the odd problems for homework to prepare for the quiz, check the answer key. And if your solutions are there, then you did it right and you're ready. And if not, you should come on to Zoom to talk to Miss Finney and myself. So let's try 28. So if we look at 28 right here, here's the problem. Now, when I see log, there's always a base and the of, right? Now, I see that down here, I don't see anything. Right next to log, I see an x. I know that it's base 10. If I don't see that base, I know it's base 10. I'm going to put that 10 down there. Now, what I want to do is, you always want to isolate the log. Think of this blue box as the thing that I want to isolate. I don't want anything in front of the blue box, behind the blue box. It's isolated. So once you do that, if you see log, you get rid of log, meaning you go to exponential form. If I see a log, I get rid of it, I cross it off. The 10 goes under the 3, and you have x equals 10 to the third. So x equals 1,000. Now, when you plug that in, it does make a true statement. So if we go back, let's see. If we go back to number 28, right, and we plug in 1,000, if we write log base 10 of 1,000, is that equal to 3? Is that a true statement? Yes, it is. Okay, that is true. So 1,000's an answer. Now let's look at number 32. So for number 32, we are going to look at it. Okay, we have variables on both sides. Now, you see that both sides are natural log, so we can cancel it out. Just as if you have the same base, right? If you had 5 to the x is equal to 5 to the 2x minus 3, we were able to write x equals 2x minus 3. Same concept. Okay, so the natural logs are gone, and we have 3x minus 3 is equal to x minus 6. We solve for x, so we can subtract. We have 2x minus 3 equals negative 6. Add 3. So we have 2x is equal to negative 3. Divide by 2. So x is equal to negative 3 over 2. Now we want to confirm that that is a solution. And when we go back to the problem and we plug in negative 3 halves, let's see what happens. Okay, so let's go back. And we'll use red. Okay, so if we go back to problem 32, and wherever we see x, we insert negative 3 halves, right? And we write natural log of 3 times negative 3 over 2 minus 3, is that equal to natural log of negative 3 over 2 minus 6. When we do that, we would get natural log of negative 9 over 2 minus 3, is that equal to, so then we have natural log inside, if we simplified, we'd have negative 7.5. Now, natural log negative 7.5, that's error, so there's no solution. Negative 3 over 2 is extraneous. Okay, for 36, we're trying to isolate log base 3 of 8x. So first step, pretend this was 7 minus x equals 2, right? If you're trying to isolate x, same concept, isolate the box. So we're going to subtract 7 from both sides. So we have negative log base 3 of 8x is equal to negative 5. Now in front, I technically have a negative 1. So if I divide both sides by negative 1, we'd have log base 3 of 8x is equal to 5. Now that I've isolated log base 3 of 8x, I want to get rid of log, so I bump the 3 to the other side, the 5 goes up, so we have 8x is equal to 3 to the 5th power, aka going to exponential form. I call it the log bump. We then divide by 8. So then we get x is equal to 3 raised to the 5th, or 243, all over 8, which is equal to 30.375. And when you plug 30.375 in, true statement. And the reason that this is a true statement, right, if we go back and we plug 30.375 in for x, if we're checking, right, which you should, we would get 7 minus log base 3 of 8 times 30.375, and we're asking ourselves, is that equal to 2? When we multiply 80 times 30.375, we get 243. And then if we do log base 3 of 243, we get 5, and 7 minus 5 is 2, and so it does check out. Okay, let's look at the next one. So for 42, when we look at this problem, right, we need to condense. Just as if you had, let's say you had 2x, right, plus 3x equals 7. You need to get like terms together first, right? So since these are same log base, we're going to condense log base 2, and we're going to multiply the ofs. So we'll have 2x times x is equal to 5. So now we've condensed the variables on the left side. We go from log form to exponential, log bump. C log, get rid of it. The base goes to the other side. So we have 2x times x is equal to 2 to the 5th power. Then from there we have 2x times x. It's just 2x times x. There's no other terms to distribute to, multiply to. So we have 2x squared is equal to 2 to the 5th, which is 32. If we divide by 2, we would get x squared is equal to 16. Then when we take the square root, don't forget the plus or minus. So we would have x equals positive 4, x equals negative 4. Now when we plug them in, we see that only 4 is a solution, negative 4 is not a solution. Because watch, if we say log base 2 of 2 times negative 4 plus log base 2 of negative 4, is that equal to 5? we get error on the left. If we plug in 4, is log base 2 of 2 times 4 plus log base 2 of 4 equal to 5. So log base 2 of 8 plus log base 2 of 4, is that equal to 5? So log base 2 of 8 is 3, right? 2 to the power is 8, so it's 3, plus log base 2 of 4 is 2. And 5 is equal to 5. That's why 4 checked out. So there's only one solution. Okay, so again, make sure that you try all of the odd problems. Again, the answers are all right here. Miss Benny and I are on Zoom at 11 if you need help and aren't sure if your answer is not matching.